which is beyond the token, a closer look at OAuth security. So this is a little introduction about me. I am an engineer graduate. I work as a product security engineer at SecurityBoat. I am also a co member and I do bug bounty hunting. So these are my social media handles. Okay, so coming to today's agenda, we are going to discuss about authentication, authorization, what is OAuth, OAuth 2.0, its evolution of OAuth, and entities to understand OAuth, the grant types, the workflows, and then the attack scenarios. So let's begin. So to understand OAuth, first we'll be doing some basic terms like authentication and authorization. So what is authentication? So as everyone knows, authentication is like verifying user's identity. So if we take an example of a website, so when we log into the website using username and password, then we are an authenticated user. So coming to authorization, it determines the user's permission. So now once we have authenticated in the website, now the website will check if we have access to the page we are viewing. So if we have, then we are authorized user, and if we are wrong, then we are unauthorized. This is our authentication. Yeah, so now we'll come to the main topic, what is OAuth. So OAuth has been used by everyone in our day-to-day digital life. So it's like when we go on a website, we can see a login page. So we'll just see username and password, and then we can see sign in with Google or sign in with Facebook click button. So we directly do the sign in with Google. We do not enter manual credentials. Instead, we will directly continue with Facebook or continue with this. So the same thing is OAuth. OAuth it stands for Open Authorization, that allows end user to grant third-party applications or services to have access to their protected resources, so which are hosted on another service. So this service is basically being used by the server for a very long time. So one such service example is Gmail accounts, and also it is a user-friendly access for the login process. So here, as we can see, this is a Pinterest page. Here we need to type email, password, and age. So instead of this, we can just continue with Facebook or continue with Google, and then we can get into the Pinterest account. So this is basically OAuth. So coming to next slide, now we'll discuss the evolution of OAuth. So first, there was OAuth 1.0. It was discovered in 2007, and it uses a complex security protocol, and also it has very precise access control of the application. And in the security, each message was cryptographically signed, so it made the whole communication flow very tough. And coming to protocol, it also used HTTP protocol, so that is unsafe. So these were the flaws in OAuth 1.0. So because of these flaws, the OAuth 1 was decrypted and OAuth 2.0 was released. So coming to OAuth 2.0, it was simple and it was easily adaptable for the application, and it used to have broader access permissions, and it was suitable for mobile and web applications. So in terms of security, it used to secure whole communication flow at once. So instead of securing each message. So that was a plus point in OAuth 2.0, and it was also a developer friendly. Developers used to find very easy to implement it. So yeah, so now we are using OAuth 2.0. OAuth 1.0 is repeated. Okay, so coming to the next slide, this is like a basic outline of OAuth. So we can see this is an end user. She is using the application using OAuth 2.0. So she'll just send the authorization request to the authorization server. Then authorization server will grant the authorization to the user, and the user will then request for the access token to the authorization server, and then authorization server will grant the access token to the user. So with the help of access token, the user will request for the resources to the resource server, and the resource server will then check the access token, and if it is correct, then grant the resources to the user. So this is like a basic outline of OAuth. So here, as we have seen resource server, end user, authorization server, resource server. So these terms are like outlines of OAuth, entities of OAuth. So here we will discuss with an example. Here again we will take the Pinterest example. So this is an end user, this is a client application which is a Pinterest account, and this is a resource server which is Pinterest server, and this is Google authorization server. Okay, so now user will go to the Pinterest account. She will get a login page, the same login page. There will be a continue with Facebook and continue with Google. So the user what should be doing? She will be directly clicking continue with Google, and the request will be going to the authorization server. Then the authorization server will check give the authorization to the user, and then grant the authorization code to the client application. Then the client application, with the help of authorization code, will give the access token. Will ask for the access token to the authorization server. So authorization server will check the code and then give the access token to the client application. So with the help of access token, the client application then will access the data from the resource server of the user. So here, resource owner will be a user, and our Pinterest account will be a client application, and the Pinterest server will be like acting as a resource server, and Google's authorization server will be acting as an authorization server. Also here we have authorization code that will be a process of this flow. So first authorization code will be there. After that access token will be issued. And this is an access token. It helps the communication flow. Yeah, coming to next slide. So before anything, well, for the user interface, now this is like an API request. So when client application will request for the access token to the authorization server, this request will be found. So here, as we can see, this is a client ID. So 1, 2, 3, 4, 5. This is a client ID, which is a unique public identifier for client application. So this is of client application. So here we can see redirect URL. It is a URL which gives the authorization server to the client application. And we can also see a response type. So response type is like a token which will be issued to the client application to get the resources from the resource server. And also there is a scope. So scope defines the level of access client application has to give the resources to take the resources from the resource server. And state is like an extra layer of security which prevents CSRF attacks. So these are the entities in the API request. Now we can move ahead. So this is like a basic code snippet. Yeah, this is like basic code snippet. So we have a Python code over here, and we are using class library. So here we will be implementing OAuth. So this is a Pinterest client again, Pinterest client secret. This will be stored in the class application, and then when the user will click on welcome to OAuth, like login with Pinterest, then this request will go to the authorization server. Then authorization server will check the user and then will give the token, like Pinterest token, to the client application. And then client application with the help of Pinterest token will give this to resource server, and then resource server will grant access. Yeah, this is about the code snippet. It is from the developer's perspective how OAuth would be implemented. Okay, now coming to grant types. So there are 4 major grant types of OAuth. First is authorization code grant type. Next is implicit grant type, and there is also password grant type and client credentials grant type. We will discuss about this briefly in next slides. So yeah, first we are discussing authorization grant type. So I will be explaining all the grant types in a way, like first I will be telling its purpose, then I will be telling its security, and then I will be telling the user interaction and the token. So yeah, authorization grant type, it is used by the secure web application to directly access the directly get the access token. So in security, it protects the client application secret and it involves server-to-server exchange. So with the user interaction, so authorization grant type, user will get User needs to consent. User needs to consent. User will consent to the client application to use the resources. Now we'll discuss the workflow. So here we have resource owner, client application, operational server, and resource server. So here user will be acting as a resource owner, and Zomato's application will be our client application, and Google server will be operational server, and Zomato server will be acting as resource server. So here, first user will access the application, and Zomato will show the login page, again the login page to the user, and then the user will grant authorization to the authorization server. Then authorization server will check the user and will send the authorization code to the client application. So here, now client application, with the help of code, will ask for the access token to the authorization server. Now, authorization server will check the code if it is correct. So, if it is correct, then we will ask the access token. Will give the access token to the client application. So, with the help of access token, client application will request the resources to the resource owner, and the resource owner will give the resources to the client application of the user. So, this is basically workflow of authorization grant type. Now, coming to implicit grant type. So this is designed for client-side application, and it is so here there won't be a code, there won't be operation code for the exchange of access token. Directly access token will be issued. In security, in the implicit grant type, user will first give the consent to the authorization server, and then only authorization server will give the access token to the client application. And in the user interaction, yeah, I just now told you, user will give consent and then send it to the resource. So coming to workflow, so here the same user will be acting as a resource owner. There will be a Zomato application, it will be acting as a client application. There will be a Google server, which will be authorization server, and also Zomato server, which will be acting as resource server. So user first will access the application, Zomato application, and will click on the sign in with Google. So the user will grant authorization to authorization server. The authorization server, here authorization code exchange won't be there directly. Access token will be issued to the client application after the user grants authorization to the authorization server. So then the authorization server will access the access token to the client application. The client application will request the resources with the access token in the URL to the resource server. So then the resource server will check the access token. With the help of that, it will return the resources to the client application. So yeah, this is the workflow of implicit grant type. Now we have password grant type. So password grant type is also known as resource owner password credentials. So it allows a client application to directly exchange the user's credentials to the authorization server. So okay, so coming to security part. So the client application handles the user's credential. So it is a little unsafe because there won't be user involved, but user's credentials will be involved, and it will be directly given to the client. It will be directly given from the client application to the authorization server. So yeah, we have the same workflow, but there are some changes. So here we have user, client application as Zomato's application, Google server as authorization server, and Zomato server as resource server. Now user will authenticate with username and password to the client application. So this username and password are of users, so this should be very secure. So it will authenticate with username and password to the client application. Then the client application will send this username and password to the authorization server. And then authorization server will check the username and password, and then will issue the access token to the client application. So the client application will take this access token and then request for the resources to the resource server, which is Zomato server. So now resource server will take this access token and use it, and then return the resources to the client application. So this is password granted. Okay, so in client credentials granted, it is used for server-to-server authentication, and this will be acting. The client application will be acting on behalf of a user, so there won't be a user involvement here. So in security, so it just the client application needs to secure the client ID and client secret. So if they are not secure, then the whole process will be unsecure. Client credentials. So this is a workflow. Here there won't be a user. This is a client application which is Zomato, and we have an authorization server as Google, and then the resource server as Zomato server. So here, without the user's consent or anything, client application will directly authenticate with client ID and client secret. And after that, after authenticating with client ID and client secret to the authorization server will directly issue the access token and give it to the client application. So client application, so here the transmission of client ID and secret should be secured. So after that, it will check and then issue the access token to the client application. Then the client application will request the resources with the help of access token to the resource server, and the resource server will then return the resources to the client application, which is Zomato. Yeah. So the workflows are looking like little similar. So I have prepared a chart over here which shows the differences between all the four grant types. So coming to first feature, it is a grant type flow like authorization grant type. It has two steps of issuing access token. So first code will be issued and then access token will be issued. So in the implicit grant type, so there will be only a single step, so directly token will be issued. Same for the password and client credentials, there won't be any code exchange, directly access token will be issued. So coming to user involvement, so authorization code, implicit grant and password grant type. So in this three grant types, user will be involved. So in password grant type, user's credentials will be involved. And in the client credentials, there is no user involvement. Okay, so coming to security, so authorization grant type and client credentials grant type is the highest secure, but whereas in implicit and password, it has risk of exposure. Like in implicit grant type, the direct access token will be issued after the code exchange. There won't be a code exchange. So in the password grant type, it is also a lower risk. So in token visibility, in the authorization code grant type, the token will be directly issued to the authorization server. In implicit grant type, the token will be visible in the URL, and in the password grant type, so the token will be directly given to the client, and in the client credentials also, the token will be directly given to the client. So refresh token. The refresh tokens are what like access. When the access token will be expired, the refresh token will be given for the long-term access. So this will be only used in the authorization code grant type, whereas in implicit password and client, in implicit it is not used, but in password and client credentials it is optional use. So use cases, so authorization grant type will be in web and mobile apps, and implicit grant type it is used in browser-based applications. And password grant type, this is only used for highly trusted application, as password will be sent from the application, client application. And the client credentials grant type, it is used only for the machine to machine, like server to server. So one example of authorization code grant type is an banking app authorization, and in the implicit grant type, we can take an example of a photo editing app, and in the password grant type, we can directly take a mobile app directly credentials exchange, and in the client credentials we can take examples of backend services like APIs. So this is comparison. Okay, so this is a graphical representation when we should use which grant type. So when we start, we need to first check if can you store the client secret in a secure place. If not, then we need to use implicit grant type. And if we can store the client secret in a secure place, then we need to move forward. Then we need to check if the client is a web application. If it is not a web application, then client credentials grant flow is used. And if it is a web application, then we need to move forward and check do users trust trust to use their own credentials. If they do not trust, then we need to use authorization code granted, and if they trust, then this password granted should be used. So by this graphical representation, we can get a glance of like when we should use which OAuth type. Moving forward, these are vulnerabilities due to improper implementation of OAuth 2. We have many vulnerabilities. These are the major ones. So there can be an improper validation of redirect URL. Also, there can be a cross-site request forgery attacks. Also, pre-account takeovers can be happen. And authentication bypass, post-attack injection, code hijacks. So there are many attacks. So these are the major ones. And we'll be discussing attack scenarios of this 3 or 4 attacks. Okay, so now we'll be seeing a I have a demo of CodeSwiggle lab. So everyone knows this is a free lab. So I'll be showing the authentication bypass attack. So this is an website. This is an website, blog website. So here we just need to log in with the credentials. We'll check the lab now. So as we can see, I'm turning on the bug to get the request in the workflow. So I'll be logging with username and password and the website blog which are given in the lab already. So the winner and bidder, these are the username and password which are already given. So now it is asking us to authorize. We'll authorize the request. And now we will take this and we'll check the authentication request in the workflow. So as you can see, we can see the authentication request in the workflow. We'll just take that and we'll send it to the repeater. So in the repeater, as we can see, the email has been disclosed, also the username is there and the token is there. So this is visible in the request. Now we'll send the request. So this is the winner email. Now we'll send the request and it is 302 form. The response is coming as 302 form. And now when we'll just change the email ID with the given another email ID, Carlos email ID. So let's check what happens when we replace the email ID. So when we replace it, we can see we got a 302 form. So there is an authentication bypass, like we just changed an email and we can get into the another account. So we'll just take this request and see it in the bug, see it in the browser. Yeah, we can see here we have solved the lab and we get into the Carlos account. So to summarize this, we can say that by just changing the email ID, we have get into the another. So if we have admin's email ID, we can directly get into the admin account and to perform actions. So this is an authentication bypass lab. Okay, so now we have profile or course or profile linking. So this is the same website. We need to log in with the credentials. So we have as username and password already given in the lab. So yeah, here we will attach a social profile. Social profile's credentials are also given. So we'll just we are attaching social media handle to the blog's website. Okay, so it is asking us to authorize. Now we'll just take this request, attach a social profile, and intercept it in the workflow. So as we can see in this request, if I submit, yeah, in this request there is no state parameter. So in the entities, I already told you that if the state parameter is not there, then there can be a CSRF attack. So there are chances of CSRF attack. Then we'll just perform it. Okay, so we have intercepted the attach a social profile request. We'll send it to the repeater. We'll just copy the URL and then drop the request so that the code is not used by anyone. So after that, we'll just go back to the lab and log out it, and we'll go to the exploit server. So with the exploit server, the request which we have copied, we'll just paste it in iframe tag so that it will be delivering to the victim, and victim can click on it and get into the account. So I have created an iframe tag, and I'll store this exploit and then deliver exploit to the victim. So I have delivered this exploit to the victim. Now I'll just refresh the lab and we'll log into the social media account to check whether we got an admin panel. So as we can see, we got an admin panel and we can perform any action. So by using that code, so there was no state parameter in the request, so we perform the CSRF attack and we just get into the admin panel. So this was the step. And next, we have OAuth account hijacking via redirect URL. So this in this we will hijack the code. So let's go on. So I'll access the lab, and same thing, I'll log in with the credentials. So now the same thing, it is asking us to authorize. So now we'll turn on the HTTP history and we'll check for our authentication request. Yeah, so we have found it. Now we'll send this to repeater. So in the repeater we can see there is a redirect URL. So if we send, the response will be going to that URL. So if we can give any arbitrary value over here, or we can give a victim's redirect URL. So the response will be going to the same URL. So here victims will be giving exploits URL in the redirect URL part and will send the request. Okay, so we can see in the response that it is going to the exploits URL. So we'll copy this URL and paste it in the iframe tag. Okay, so as we can see here, this iframe in the iframe tag. First, this is our Web Academy link, Web Academy ID, which is given in this request. This is a host, and then there is a client ID, which is our client applications ID, and we have redirect URL, which we have taken from the URL of exploit. So we'll store this and then deliver this to victim. So we have stored this exploit, and now we'll view the exploit. We can see iframe tag over here. We have got code sweepers lab in the iframe tag. Now we'll deliver this to victim to check if they have logged in. We need to check the access log. As we can see here, the code is leaked. So now what we can do is now the code is leaked, we can just copy this code and paste it in our request, OAuth request. So I'm copying the code and I will paste it in the OAuth request. We already have the OAuth request. When we log in, in the STP history, we can find it. So here, as we can see, we have got OAuth request. So we'll take this and we'll send it to the repeater. And here there is a code already. So what we'll do, there's a leak code which we got from the access log. We'll just copy that and we'll paste it to the repeater. And we can see we got a 200 OK response. That means our code, the leak code has been used. And then when we copy this request and paste it in browser, we can see we get an admin panel and we can perform the actions. So to summarize this, we can say that when we redirect URL to the exploit server, then the code is linked, and by using the link code, we can get into the admin panel. So this is a flaw. Yeah, these are the attacks. Okay, now coming to remediations, as we have seen, so we need to have state parameter in the request. If the state parameter is absent, then there can be a CSRF attacks, and we can perform any actions. So also we need to implement JWT with proper signature for the tokens, and we need to check the redirect URL. So it should be in a proper format, so that the redirect any request, any arbitrary value cannot be stored in the redirect URL. So that will be mitigating the risk of injection attacks. And we need to avoid storing tokens in the client side, because they are very unsecure. And coming to this client secrets and access token. Okay, so we need to every time check the logging of OAuth activities, so that there won't be any security attacks. So we need to check every time. So this is all from my side. If you have any questions.